Alright, next I'd like to go over example 4. Solving log base 3 of m plus 12 minus log base 3 of m plus 5 equals log base 3 of m. So my first step will be to write this as a single logarithm. So to do that, I'm going to use the quotient property. We have a subtraction sign right there. So when I write that as a single log, I get m plus 12 over m plus 5 equals log base 3 of m. Step 2, I want to write it as log base a of x equals log base a of y, which implies x equals y. So I'm using the property that the argument in this log must be equal to this log if the bases are the same. So the argument in this log is m plus 12 over m plus 5. The argument in this is 12. The next step, step 3. I'm going to solve the rational equation. So I do that by multiplying both sides by 5 plus m. When I solve that, I distribute the m, and I want to set it equal to 0. So I subtract m and minus 12 from both sides. So I'm subtracting this m over here from 5m, because they're like terms. I'm subtracting plus 12, so I'm doing minus 12 from both sides. This does not have a like term, so I will now simplify both sides and see that I get 0 on the left hand side, and I get m squared. 5m minus m is 4m minus 12. Next I want to solve this polynomial. I can do that by factoring with a quadratic formula. I'm going to try factoring first. If I factor that, I see that m plus 6 and m minus 2 will work. Now I can solve the factored form of the polynomial, find the zeros. I find m equals negative 6 and m equals 2. I'm still not done because I want to check both of my solutions by plugging them back into this equation, which you probably want to use a calculator to do. So when I do that, I see that log base m of negative 6 is undefined. So m equals 2 is my only solution. Plug m equals 2 into both of these equations, and you'll see that the left-hand side equals the same thing as the right-hand side.